Okay, so in this video, we're going to take a closer look at independence and mutually exclusive or disjoint events, and try to more concretely show that mutually exclusive does, and in no way will ever mean, does not mean independence. As a matter of fact, the contrary is true. So we have a deck of cards, and we're choosing a card at random. And I want to know the probability that the card is a king or a heart. So we're looking for the probability that the card is a king or a heart. Well, or means this is a union of two events, those two events being the probability that the card is a king, as well as the probability that the card is a heart. Okay, so the probability that the card is a king is 4 out of 52, or 1/13. The probability that the card is a heart is 13 out of 52, or 1/4. However, as is always true with the union of events, we need to look at the potential of overlap. Are there any events which are counted twice? And if there are, then we need to subtract them out. So we know that the probability of A union B is P of A plus P of B minus P of AB. So currently we know that the probability of A is 1/13, and we know that the probability of B is 1/4. The question is, what is the likelihood of a card being a king and a heart? Now, obviously, if you know a deck of cards well, you know that there's only a king of hearts, so that's 1 out of 52. But let's talk about that from a mathematical standpoint as well. So we know that we're going to subtract 1 out of 52, but what's the probability that a card is a king and a heart? Well, that would be the probability that a card is a king multiplied by the probability that a card is a heart, given that it's a king. Now, the probability that the card is a king, we know, is 4 out of 52. The probability that the card is a heart, given that it is a king, means we're only looking at the kings. So out of 4 cards, what is the probability that the card is a heart? Well, out of the 4 kings, there is 1 heart. And if we look at that and compare it to earlier, we have this probability heart given king is actually the same thing as the probability that the card is a heart. These two events, being a heart and being a king, are independent events. The card being a king does not affect the probability that the card is a heart. Thus, we still get our 1 out of 52. So from the very beginning, had I done 1/13 times 1/4, I would have received 1/52, and that's because, again, the card being a king does not change the 25% probability that the card is a heart. So I subtract out 1/52. Okay, so just some common denominators here. I end up having 16/52. Because this is 4 out of 52, this is 13 out of 52. Subtract the 1, so it's 16/52, which can reduce to 4/13. Okay? Now, A and B, the king, card being a king and the card being a heart, are considered independent events. Why are they considered independent events? Because this probability is equal to this probability. The first event did not affect the probability of the second event. The king and the heart, king or heart, those two events, are also considered joint events. If I were to draw a Venn diagram, here we have king, here we have heart. There is some overlapping region, albeit small. There is a card that is shared by those two events. So these are joint independent events. Now, suppose I said the probability of the card is a king or a 2. Now, in this case, the probability that the card is a king is still 450 seconds. The probability that the card is a 2 is also 450 seconds. When I try to determine the probability that the card is a king and a 2, well, the probability the card is a king is 450 seconds. The probability that the card is a 2, given that it's a king, if the card's a king, it can't be a 2. 0 out of 4. So the probability that the card is a king and a 2 is 0. Thus, the probability the card is a king, union, the probability is a 2, would equal P of k plus P of 2 minus 0, or 2/13. Now, in this case, if I were to draw my Venn diagram, I have king, I have 2, and I have no overlapping region. These events are mutually exclusive. They do not overlap. However, because this probability is not equal to this probability, because being a king affected the probability that the card was a 2, these events are considered dependent events. So this is extremely important. These mutually exclusive events are not at all considered independent. Quite the contrary, they are considered dependent events. As a matter of fact, that is always true. If two events do not overlap, then the probability of them happening together must be 0. If they cannot happen together, then either the probability of one of them is 0, which doesn't really make sense, or the probability of one of them happening given the other must change to 0. Thus, mutually exclusive events must be dependent events. So please do not confuse independence with mutually exclusive.